Okay, it's very nice to be with all of you today. Thank you very much, TechPro, for organizing this very nice webinar. So my name is Gwen, and I will be talking today about beam shaping for process improvement, either yield, either quality, with our technology, which is called MPLC. And please do not hesitate to write any question you will have in the chat. I would be very happy to answer your question at the end of the presentation. So I will just shortly tell you what we Cailabs provide, because we are here to talk about beam shaping, but what exactly do we provide in terms of beam shaping at Cailabs? I will get into our technology and talk about MPLC and how it works exactly, and how we can improve the processes. I will also let you know some results that we have already got, which are linked to the Custodian project. And I will finish by saying everything we want to do inside Custodian and what we are already doing for each of the Custodian applications. So what does Cailabs provide? Well, Cailabs, most of you may not know us yet. We are a pretty young company. We are only 7 years old. We are based in west of France. And we are a deep tech company, meaning that we want to really push the technology forward and the innovation forward. And we have developed a unique technology, which is called MPLC, for multiplane light conversion. We are doing beam shaping, but we don't think beam shaping similarly to other technology. We don't work based on ray tracing. We don't work based on diffraction. We work based on mode propagation. So because it's very new, it's been patented from the beginning, and it actually enables to do a lot of things in different applications. And many people did trust us over the years, and we did raise 17 million in the last years. So we are a little bit more than 50 now, most of us in red. As I was saying, I will be quick on that, but this technology can apply to a lot of different applications. We have done a lot of telecommunication in the past. CANUNDA is for the local network, Proteus for the network of the future, TILBA for the telecommunication between ground and satellite, which is called free space communication. And in Cailabs, we have a lot of other applications like defense or biology. But today we are here to talk about material processing. So in Cailabs, we really want, with our beam shapers, to improve laser material processing, meaning whenever you have a laser in a factory or in a workshop which is processing goods, we want to look at it and see if we can improve the processes. So how do we do that? How does actually MPLC works for the improvement of the yield and quality? Just want to quickly say that actually we depending on the process you want to improve, you are implementing systems which are very different. So today we are here to talk about high power application, may not be clear yet, but everything that has been discussed yet is with really CW high power lasers, meaning multi-kilowatt lasers. And in Cailabs, we call that CANUNDA HP. So today I will just talk about this product line on all the related topics to CANUNDA HP. But we are also working on burst application compatible with USP lasers or on Axicon for bezel beam generation. And in every cases, we are happy to discuss catalog references or custom development, as we are doing actually within Custodian. Now, why beam shaping for material processing? It's been said already somehow in the previous talk from my colleagues. Actually, it's very important to have the right shape if you want to really improve the process, any kind of process actually that you want to do. Here are just a few examples. For laser beam welding, for example, there is some literature saying that this shape is just an example. It's not the shape that we will apply in Custodian, but it's been proven that having a line and a dot behind is very helpful for laser beam welding. In the case of Custodian, we plan to really eliminate most of the defects thanks to the beam shaping. For cutting, the shape is actually pretty different in the literature. You can have, for example, this dot with a C shape behind, and this is really improving the speed of the cutting. Within the Custodian project, we can target to actually multiply the speed by a factor of 2. In additive manufacturing, the shapes which are looked at are pretty different. So it can be this symmetric shape. There are also non-symmetric shapes, just as my colleague from TU Vienna discussed. And the idea is actually to enable the additive manufacturing of new parts. So it's really to compare how to manufacture those parts with 3D processing compared to other technology. What you can see here is that all the shapes are very different, very complex, and are actually non-symmetric. So they are not easy actually to make. And that's where we go to actually MPLC. If you want to do really complex shape to improve your processes, you have to be able to do really free-form beam shaping. And this is not possible with all beam shaping technology. So what we do in Cailabs is multi-plane light conversion, meaning that actually you have a lot of planes, you have a lot of face plates, and in between them you have propagation, as you can see on the bottom left of the screen. Because we have so many face plates, we have really a good possibility to tune the shape that we will do with our system. So we can resolve complex equations in terms of intensity profile, meaning freeform. With a very high quality, we can reach the limit of diffraction in terms of quality. And actually, which is very unique, we manage also to solve the equation of the phase. So we can have a plano phase where we have the shape. This is extremely important in terms of beam shaping if you want to have a robust process. Many beam shapers, they don't have a plano phase, and at the end, they have a very small depth of focus where you have the nice shape. This system is fully passive, as you can see in the image in the middle. You don't have anything electronic to pilot it. It's therefore very robust and actually pretty easy to manipulate. Over the years, we realized that it was much more convenient to implement it in a reflective way. So that's what you can see on the picture on the bottom right. You have textured mirrors on one side, then another mirror in front, and the light is going back and forward in between both mirrors, being shaped slowly faceplate by faceplate. Because it's fully reflective, actually it can handle really high power and really high energy. It is actually very nice. For example, one important point is you can have a smooth cooling, meaning that you just have to have a water block behind the optics, and it will cool down the whole optics a very homogeneous way. So you can handle high power and you can do it very smoothly compared to, for example, transmissive optics, which are generally cooled down by the edges of the optics, and then it's less homogeneous over the lens. One point which is actually very important sometimes for high power processes as well, we can handle multiple input and we can handle multiple output. So all this make it a very good candidate if you want to do complex beam shaping to improve the processes. So that's what MPLC is actually providing. Now, what result did we got already? So here actually you can see one system on the robot that we have developed, which is kind of a first step for the custodian project. And we did manage to check a lot of different things with this system, which is very new. It was manufactured last December and tested for the first time in January. And we have some more tests with a similar system scheduled for this week. So we are really working on that to improve our design. The idea of that system was to improve laser beam welding with a simple shape. And actually, it was mainly to make a compact system. So it's the first time in Cailabs that we do such a compact system, which is integrated in a robot. About a year ago, we were only doing R&D on optical benches. So it was a big improvement, which we are quite proud of. We did test that with the Institut Maupertuis. It's an application laboratory in the west of France as well. So the idea was to have actually a collimating mirror at the beginning in front of a standard LLKD fiber input. At the end, you have a focusing mirror, and in between, you have the MPLC, you have the mirrors which are doing the shaping of the beam. I will just go quickly through a few technical parameters that we managed to achieve with the system. We had a very nice transmission, more than 99%. We were actually in the measurement precision of the system. We managed to preserve the BPP before and after the shaping, which is also very unique to MPLC technology. We managed also to reduce the focus shift. So I remind you one more time that it was the first time we have such an integrated system. And already we got very good results in terms of focus shift, thanks to the cooling down by the back of the optics. And we actually plan to get even better results than that very soon. And we were also able to handle really high power. And beam shapers handling 16 kilowatts are not that numerous, actually. So we were very happy to manage to handle 16 kilowatts for laser beam welding. So here actually are some of the process results that we got. You can see the video. I was also very happy to have this nice video. So you still have some spatters, mainly because we don't have actually protective gas shield in the system, didn't have time to implement it. But it was actually the first weld that we were doing with an MPLC, and we were very happy of the quality of the weld, which is actually quite nice already. And as you can see, it's already integrated in the robot. So what beam shaping for the custodian project? I guess that's the most important part of my talk now, but everything is actually getting to that point, and you will see the link with what we just said before. First thing I want to say that one of the huge challenges that we want to tackle with Custodian is the dynamic beam shaping. It's actually not easy to do dynamic beam shaping, but if you want to adapt the beam during the process in live, as my colleague just explained how important it is, you have to have some dynamic parameters which you can use. So whatever we want to do actually is based on what we call parameter transfer feature, and it's been proven already that it's working well. In the past, you have the paper name at the bottom of my slide. And what you do actually is that, for example, you change a tilt at the input of the MPLC into a defocus at the output of the MPLC. It can be any kind of other parameter. You can change a tilt at the beginning of the MPLC into a shape dimension change, for example, or into the distance in between the shape that you will change. Everything is actually somehow possible. Just have to look into the details on what you want to do. And on the right, you can see an image of what has been done already with multiple inputs. And this is a demonstration of the capability to do dynamic system. So now let's talk application by application. So the challenge of beam shaping for laser beam welding, actually, there are many challenges, but I would say that I would like to say that one of the challenges is actually to be integrated in a laser head. So that's why we did this project with Institut Maupertuis before, because it was a huge challenge to make something which can be integrated in a robot, which is compact, light, and can handle the speed of an arm robot. So we are very happy that on that point we did actually good improvements. We have to be compatible with a Precitec welding head, and it has to be an add-on which is easy to integrate. So it's a challenge that we have to meet as well, but we are already working very well within the Custodian project to tackle that point. Now it has also to integrate an inline control of the process. It is also a challenge, but this will be discussed also later on during the webinar. The shape that we will target is a complex non-symmetric shape. Complex non-symmetric shape is difficult, and not all beam shapers enable that. So the idea is to initiate the melt with, as Rodrigo was mentioning, kind of a first point or a main beam, and then to control the melt put with a secondary beam. All that we will do it preserving the high depth of focus, which is extremely important if you want to do welding through a large, thick material. And last but not least, this is to be dynamic so that we can adapt in the process in live. So it's going to be a very nice actually shape that we will do for laser beam welding. For LPBF application, actually the challenge will be very different. We don't have to be integrated in a laser head, but we have to be integrated in a machine. So on the bottom right, you can see how we plan to do that. We will have to have a very long propagation, and we will have to have a very flexible system in order to test different shapes. As you saw also on Rodrigo's presentation, there is actually a huge number of possibilities which can work for LPBF. So we try to have a flexible system which enables testing different shapes to improve the process. Again, we will preserve the depth of focus, even if it's actually less important for LPBF than for laser beam welding. And it has to be dynamic for the live control of the process. Last application is laser cutting. So in that case, actually, we are able to show you a CAD model of what we plan to do. It has to be compatible with the Precitec light cutter. Again, it's going to be a non-symmetric shape, so a difficult shape to make, but very efficient in terms of process improvement. And one of the challenges that we will have to meet in that case will be to be compatible with a dynamic focusing system, meaning that the last lens, the focusing lens, will be a standard lens from Precitec, which can adjust the focus so that you can adapt the focus to the process that you are doing. And on that specific case, we will have very nice results probably next month. And I would suggest that you follow us on the LANE conference, the Cailabs conference, to see the last result actually this fall, including actually an online high-speed X-ray imaging, which will be done by Precitec, and we are really looking forward to this test, which has to be done in September. So now my conclusion slide. What Cailabs provide is in Custodian actually is high-power beam shaping, which is fully reflective. It is very important because it enables to have an homogeneous cooling, and it also enables to reduce the focus shift. What we provide also within the project is a freeform shape, so you can have symmetric or non-symmetric shapes, and you can actually include also beam combining if you wish for your application. we are already handling high power, and very probably actually inside custodian it's going to be less power than that, but still high power. And we will have our beam-shpaer, we will enable the live control of some parameters of the beam shape in order to adapt to the process. So I think that's it for the beam shaping. I tried to explain where we get from and where we want to go within Custodian, and I will be very happy to answer any question that you would have.